Here we have two semi-infinite wires which are placed on the x-axis, one from minus infinity to minus d and the other from d to infinity. Both wires carry a steady current I in the same direction. So we have a situation like this. This is our x-axis. This is wire 1. This is 2, wire 2. The wire 1 is extending from minus infinity to minus d and wire 2 is extending from d to infinity. Now both the wires are carrying a current I, steady current I in the same direction. Now what is the question? The question is asking us to find the magnitude of magnetic field at a distance d away from the center of this gap in the YZ plane. So center of the gap is this. This is the center of the gap. From there at a distance d, we have to find magnetic field. To do this question, what we can do is, we can first find the magnetic field due to an infinite wire, an infinitely long wire which is extending from minus infinity to plus infinity at a distance d, at a perpendicular distance d. So let's say this is b1. Then what we do is, we will find the magnetic field at a distance d due to a finite wire which is extending from minus d to plus d. Then let's say this is b2. Then we will subtract b2 from b1. We will subtract b2 from b1, then we will get the magnetic field b. B is the magnetic field here. This is what we are going to do. We know that the magnetic field due to an infinitely long wire at a distance d, the wire is carrying a steady current I, then the magnetic field is equal to mu naught I upon 2 pi d. This is the magnetic field at a distance d perpendicular from an infinitely long wire which is carrying a current I. So b1 is equal to mu naught I divided by 2 pi d. Now when the wire is finite, the magnetic field is given by, the wire is carrying the same current I. Magnetic field b2 is given by mu naught upon 4 pi d times sine theta 1 plus sine theta 2. Here theta 1 and theta 2 are these angles. This is theta 1. This is theta 2. Now from the geometry it is clear that theta 1 is equal to theta 2 is equal to 45 degree, because we have this side, this is equal to d, also this side, both of them are equal to d, this is also equal to d. So from there we can say theta 1 and theta 2 are equal to 45 degree, which means b2 is equal to mu naught upon 4 pi d times sine of 45 degree is 1 by root 2 plus sine 45 degree which is 1 by root 2. This is equal to mu naught upon 2 pi d 1 by root 2. Therefore magnetic field B is equal to B1 minus B2. This is equal to B1 is mu naught I upon 2 pi d, B2 is mu naught I upon 2 pi d into 1 by root 2. I missed an I here. There is an I here. In the formula for B2 we have an I here. Edit this. Therefore we have B is equal to B1 is mu naught I upon 2 pi d and B2 is mu naught I upon 2 pi d times 1 by root 2. If we take mu naught I upon 2 pi d common, we have B is equal to mu naught I upon 2 pi d times 1 minus 1 by root 2. Therefore the correct option here is option B.